So, knowing all these theorems now, you can now start using it to calculate one problem or the other. We can use it to solve some problems in mathematics. So, let's look at our problem, then we'll now solve it through Now let's look at this question. This question says, this is a Y exam. Question says you are given a circle, then we have Q R. This is a S T, and this one, and this one comes this way. Then this angle is 98 degrees. This angle is 131 degrees, and this is our P. Okay. Now the question says in the diagram, angle ROT equals to 131. You have what? It will be RQT. Angle RQT equals to 131, and Q angle QTS is 98 degrees. QTS is 98 degrees. Yes. The question now says RQP and PTS. What happened to them? Are straight. They are straight lines. Okay. One, we are to find the value. Of angle QRS. We are to find the value of angle QRS. 2, we are to calculate the value. The value of angle QPT. And 3, we are to show that angle PQT is angle P. What is it? PQT is what? Isosceles. Is isosceles. This is the question given to us to calculate. This is the question given to us to calculate. We are going to itemize it one after the other. We are going to itemize it one after the other. But the first thing is, let's get the diagram cleared. We have been given a sample. This is one called sample theorem. Okay. We are now asked to find the first one, which is question 1. Question 1. We have to find the value of QRS. 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 This is how we find the QRS. QRS. Let's look at it. QRS. We want to find this angle. This is angle QRS. How we find angle QRS? If you look at one of their theorems, I've said it earlier, we are to say that if you look at it very well, QRST is what? A cyclic quadrilateral. It's a cyclic quadrilateral. Please get yourself familiar with all these things, because in the exam they won't tell you that this is it. You see that they did not mention anything like cyclic quadrilateral in the question, but it is you that will know that this one is cyclic quadrilateral. Look at it. QRST is a cyclic quadrilateral. And I said earlier on that in the cyclic quadrilateral, the sum of opposite angles are what? They are supplementary. The sum of opposite angles are supplementary. So in this case, if QRS is this, we have to find what? QRS. QRS. This is the one we want to find. Which one is opposite to it? The one opposite to it is QTS. These two angles are opposite to each other. So we now say that QRS, this angle, I put the sign of angle on that because I'm trying to angle out. QRS plus QTS plus QTS, this angle, that is the one that was facing each other, they are opposite to each other, must be equal to what? It must be equal to 180, because we said the sum of opposite angles must be supplementary. Supplementary means they must be equal to 180. That's the meaning of supplementary. Once they are equal to 180, then what is the next thing? We are looking for what? We have to find QRS. QRS equals to 180 minus QTS. QRS must be equal to 180 minus QTS. What is QRS now? QRS is 180 minus QTS, which is 98. Subtract 98 from this. This gives us what? This gives us 82 degrees. It gives us 82 degrees. What is 180 minus 98? It will give us 82 degrees. It means the value of angle QRS is equals to 82. That's how to force off for that one. We'll go ahead with the next one. The next one says calculate the value of QPT. Calculate the value of QPT. When we look at that one, we try that RQT number 2. We want to find angle QPT. We want to find angle QPT. So here we say that one RQT. How is our RQT? RQT. This angle RQT. That's it's on the straight line with our P. Is equals to what? Is equals to angle what? Which one is equals to? This is RQT is this angle. We are referring to this angle. Then with this angle to TQP or what? Okay, sorry. This is a 131. We say it's a cyclic quadrilateral. Then RST. RST is also opposite to this one. RST is opposite to this angle, and we said in the cyclic quadrilateral the two angles are what? Supplementary. So we say RQT plus RST equals to 180, because they are what? Opposite angles in a cyclic quadrilateral. So meaning that RQT is what? 131 plus RST is equals to what? We don't know the value of that one yet. Equals to 180. RST equals to 180 minus this. RST equals to 49 degree. RST equals to 49. When you subtract 131 from this, it gives 49. That means this plus this must also give us 180. And this plus this must also give us 180. Where are we going? We have to calculate what? Angle QPT. We have to calculate angle QPT. Where's our Q? QPT. We are looking for this angle now. We are looking for this angle QPT. How will we arrive at that one? It is very easy. QPT will be equal to what? It will be equal to this one. QPT, because this one is now outside the what? Outside the circle. It is outside the circle, and it must give us angle 49. It must give us angle 49, which is parallel to this one inside the circle. Alternatively, if you want to get it, you can still go ahead finding the angles to this one. Subtract this one from 180, this one will give you 82. Subtract this one from 180, this one will give you 49. So 49 plus 82, you add it together, subtract from 180 will give you this angle. That's another alternative way of doing it. Once you know that this is a straight line, I will know that angle on the straight line is equals to 180 degree. You know one of the angles to be 131, the other angles will be 180 minus 131. You know this one is a straight line, this is 98. Subtract 98 from 180, whatever you have here will be the other one, being an angle on the straight line. Now that this is a triangle again, QPT is also a triangle. So you can find the value of this angle, the one you have already calculated now, and the value of this one that I have calculated, add it together. Subtract from 180 will give you the value of this angle. So that's another method that I expect you to use. Solve it on your own and see whether you're going to arrive at 49. So definitely you must get 49. Now, the other way around. What is the next question? We have to find, show that PQT is isosceles. PQT is an isosceles. So what is it? We talk of a PQT. Where's our PQT now? PQT will be equal to what? 49. We said this one is 49. This is 49. If you subtract 131 from 180, it will give you 49. If this is 49, this is 49. What you are saying now is this. If you want to find PQT plus what? Plus TQR will be equals to 180. That is the sum of angles in a straight line. Sum of angles in a straight line. The sum of angles in a straight line is equals to 180. And the one we are talking about now is a straight line. If it's a straight line, it means our PQT plus TQR must be equal to 180. But if you look at it very well, TQR is 131. So we say PQT plus 131 gives us 180. PQT equals to 180 minus 131, and that gives us 49. And that gives us 49 degree. That gives us 49 degree. So that is the value of our something here. But we have to show that it is what? An isosceles triangle. This isosceles triangle means, what is an isosceles triangle? That should be the next question to you. We said that an isosceles triangle is the angle that what? An isosceles triangle is a triangle with what? Two sides equal. If the two sides are equal, the base angles are also equal. Now, note that isosceles triangle are triangle with two sides equal, and then two angles, or let's say the base angles are also equal, and the base angles are also equal. The base angles are also equal. The base angles are also equal. In any isosceles triangles, if truly what you have to do here, PQT, is an isosceles triangle, these are the conditions that you have to look for to confirm that truly it is an isosceles triangle. Because we want you to prove it to us that truly it's an isosceles triangle. If PQT is an isosceles triangle, two sides must be equal, then the base angles must also be equal. Unfortunately for us here, they've not itemized us, they've not tell us the values of the sides. So you cannot confirm that the sides are equal because there is no value of the sides given to us here. That's another thing you have to understand, that in most cases you may be given sides and you may not be given it. If you are given sides, fine. If you are not given, fine. What you need to note is you have to understand each of these things. What is an isosceles triangle? What condition can a triangle be an equilateral triangle? Or what condition can a triangle be a right angle triangle? You have to note all these values. Once you can identify it, then you can solve your problem. Now we see that no size is given to us here, but we still say that there are two conditions that can make a triangle to be an isosceles. The first condition is that two sides must be equal. Then the base angles can also be equal. Once you have the sides here, we don't know whether it is equal, but let us check whether the base angles will be equal. Come back to the diagram. You see that come back to it. You see that QPT, like we found the other time, was 49. QPT was 49. Now we find PQT. PQT is also 49, which means they are what? They are equal. It is 49, this is 49. They are equal. Therefore, you can now say that since angle QPT is equals to angle PQT equals to what? 49 degree, equals to 49. Then you can now conclude that what do I have to conclude? Angle triangle PQT is an isosceles triangle. Is an isosceles triangle. Triangle PQT is an isosceles triangle, and that is what you are asked to prove over there. That is what you are asked to prove over there. So that is that, and that is the first thing that we have to solve. Then we will now go ahead with other calculation. Supposing we are given this. Alright, this is another question. In the diagram, 0 is the 0. In the diagram, 0 is the center of the circle. 0 is the center of the circle. AB is circle AB. In the diagram, 0 is the center of circle AB. 0 is the center of the circle. Rather. AB is a diameter AB is the diameter and BAC, angle BAC is equals to 40 degree. Find angle ABC. Find angle BOC. In the diagram, is 0 in the center of the circle, is 0 in the center of the circle. AB is a diameter, AB is a diameter, and BAC is 40 degree. Find it. So this is the diagram given to us in the question. You have been given a question this way. There is a center, and that center there is a line passing through the center like that, called AB. Then we have another one this way, another one this way. See, this place has been divided into two, and this angle is 40 degree. So this is the diagram given to us. Now we are asked to find ABC. Where is ABC? ABC. Look at the diagram. It's a circle theorem. What type of circle theorem is this? That is the first thing that must come to your mind. If you look at the diagram very well, it's a circle theorem. What type of circle theorem is this? We said that in a semicircle, this is angle in a semicircle now, because AB is a diameter. It passes through the center. This is like AB. By the time you are drawing it, it passes through the center to this place. That means AB is a diameter. And we said diameter divides a circle into two equal parts. Then the angle formed in a semicircle is what? Is a right angle triangle. These are that theorem that you have to know offhand. They will not tell you that they will not tell you in the exam that this is an angle in a semicircle, but it is you that will know that, oh, this is what they are referring to. So angle in a semicircle, just like I proved to you from the beginning, this is an example of angle in a semicircle. It is equals to 90 degree. Where is our 90? This place, the whole lot of this place form 90. Not only this or this, the whole lot of this place form 90. Now, if all this one form 90, this place form 40, you can easily find ABC using that theorem now. Solution. So we have to find one. We want to find angle ABC. What is the ABC plus what? BAC plus BAC, alright, plus ACB plus ACB. Everything must be equals to 180. That is the sum of angle in a triangle. ABC, this angle, plus BAC, this angle, plus ACB, the root of this angle. Everything must be equals to 180. That is the sum of angle in a triangle. Now we say that angle ABC, that is the one we are looking for. So we say angle ABC plus angle BAC. What is our BAC? BAC is 40 degree plus ACB is 90 according to our theorem, the one I proved to you in the beginning of this lesson, equals to 180. ABC plus 130 equals to 180. So angle ABC equals to 130 plus this, which is equals to 50 degree. It is equals to 50 degree. So angle ABC that we have to calculate now will be equals to 50 degree. And that is how to arrive at that one. The next one will be, we want to find BOC. We want to find angle BOC. The first thing is identify where angle BOC lies. This is B, this is our O, center O. Question says center O. This is our center O, BOC. Now, look at it, BOC. BOC is what? A triangle. BOC is a triangle. What type of triangle is this? BOC. We know BOC is a triangle, but what is the name of this triangle? That is the first thing that must come to your mind. What is the name of this triangle BOC? Clearly, you see that BOC is a triangle called what? Isosceles. It's a triangle called isosceles. It's an isosceles triangle. Why? Why do we say it's an isosceles triangle? It's clearly seen. If you look at BO is a radius, and OC is also a radius. Two lines, two sides are what? Are equal. This is a radius, this is a radius. It's now telling us that if radius is 10 centimeter here, this one will also be 10 centimeter. If this place is a 7 centimeter, this one will also be 7 centimeter because they are the same radius. So once two sides are equal, then the triangle becomes what? An isosceles triangle. At least we have identified one of the properties that makes an isosceles triangle. And two sides must be equal. This side is equal to this one. Then it has formed an isosceles triangle. Then the next thing is, if it has formed an isosceles triangle, identify the angle given. We have already calculated this one as a ABC, the one we calculated on, to be what? 50 degree. This angle is 50 degree, right? Now, where are the base of angles of this BOC? Then the base angle. The base angle of triangle BOC are what is that? Base angle now be OBC. OBC must be equals to what? B, or say OCB must be equals to OCB. OBC, this angle must be equals to OCB, this angle, because the two of them form the base angle of isosceles. They are the base angle of isosceles. Now, once they are the base angle of isosceles, what are you looking for? We are to find BOC. We are looking for BOC. Now that we know that this angle is 50, definitely this one will also be 50. So we can now say that OBC plus BOC, that is what you asked to calculate now, BOC plus OCB, everything must be equals to 180, meaning that the sum of angle in a triangle. What is a OBC? OBC is what? OBC is a 50 degree. BOC is that, and the OCB is a 50, and that gives us 180. That's what gives us 180. Now we have BOC plus 100 equals to 180. Okay? Then our BOC equals to 180 minus 100. Therefore, BOC equals to 80 degree. BOC now is equals to 80 degree. And that is what we are asked to find here. Our angle BOC will be equals to 80 degree. That's how to solve such problem. We are still going to look into another one. Let's look for another past question.